Hello and welcome to the session hosted by Aakash. As it's very clear from the backdrop, this particular session is meant for discussion of physics paper that was conducted as Paper-2 for JEE Advanced on 22nd May 2016. So here I am to discuss code 2 variety of the paper, and the first question that I have is from thermal expansion. This is quite a nice question. Let me explain first. There are two rods PQ and RS which are soldered together here. They are joined. Initial temperature is 10 degrees centigrade. The length is given. The coefficient of linear expansion is given. The thermal conductivity of this is twice as compared to this. Initially the temperature was 10 degrees centigrade, but then later on this changes was made. P is maintained at 10 while S is maintained at 400 degrees centigrade. Now, based on this, we need to calculate the change in length of PQ. The question demands a lot of calculation, so let's try to see. The first thing is, let's try to calculate the temperature of the junction. In order to do that, what we can see is, if this resistance is R, this resistance would be 2R, because straightway this thermal conductivity is twice, so resistance has to be halved. The length and the cross-sectional area is same, that's the reason. And this is 10 degrees centigrade, this is 400. So first let me calculate the temperature of the junction. 400 minus theta by 2R is theta minus 10 by R. The series combination that I used, that would be 400 minus theta is 2 theta minus 20, and this would be 420 equals to 3 theta. In other words, theta is 140 degree. This is the temperature of the junction. Now the point is, to find the increase in length, I cannot directly use the formula of alpha L delta theta, because the entire rod is not at one single temperature, it's at many different temperature. So what will we do is something like this. Consider this particular length. Now say this is at 10 degree, this is 140 degree. So the rate of change of temperature with distance or temperature gradient is 130 degree per meter, because the length is 1 meter. So what we'll do, at a distance x, let me go, I'll consider a small length dx. dx is not the increase, it's a small length. Let's try to find how much is the temperature here, theta. So that theta would be 10 plus 130 x, because 130 degree per meter is the temperature gradient. So 10 plus this much would be the temperature there. Now all of us know delta L is alpha L delta theta, where delta L is the increase in length for length L. Now here the small elongation, why small? Because we are considering for the length dx. So that would be alpha, the length is dx, and the change in temperature. This is the present temperature. The original temperature was 10. So the change would be 130x. That's a small elongation. The total elongation we got to integrate. The integration of x will have a limit from 0 to 1. That will give me the total elongation. And when we calculate it, it demands calculation. I do agree. And that will give us to option number A as the correct answer. So that was for question number 1. Now we'll move to question number 2. Question number 2 is another beautiful question which is made from nucleus, and the question has been very thoughtfully placed. Many ideas have been imported. Generally, you don't find this sort of numerical in your practice book. It says the electrostatic energy of Z protons uniformly distributed in a sphere. If all the Z protons are smeared in a sphere, then in that situation you see, you get this much of the energy. Assuming that the difference between the binding energy of nitrogen and oxygen is purely due to electrostatic energy, we need to calculate radius of either nuclei. And one assumption that's given by the question, the radius has to be taken to be same. Rest all the data are given in front of you. Let's try to calculate. This involves quite nice of arithmetic. So here, something like this. First of all, what we'll do is binding energy of nitrogen, if I see, that will be 7 mp plus 8 mn minus mass of nitrogen C square. Likewise, binding energy of oxygen would be 8 mp plus 7 mn minus mass of oxygen C square. Now we can easily calculate the difference, although the arithmetic is quite tedious, but you have to do, there is no other option. Similarly, En would be 3 by 5 E square by 4 pi epsilon naught R, and nitrogen has this as 7, so that would be 7 into 6, 42. Likewise, energy for oxygen would be 3 by 5 E square by 4 pi epsilon naught R, so that would be 8 into 7, which is 56. Now here we calculated the binding energy by the regular method, and this is the energy of the sphere. Now according to the question, the difference of this is equal to the difference of this. So if you equate that, the option that you get would be 3.42 Fermi-meter. So option number C would be the correct answer. Now let's move to question number 3.